Not all angles are created equal. Some angles are going to be special angles in terms of trigonometry. We're not going to need the calculators for this next bit. So we're going to make two special triangles actually, but we're going to make one special triangle at a time. So the first special triangle is going to be like this. Now what we know, and we're going to say that this is 1 and that's 2. And we could calculate the length of that side. I'll kind of do it on a side paper because I don't want to mess things up. Because we know that 1 squared plus that side squared is 2 squared. So x squared is going to be 4 minus 1. X squared equals 3. So x equals root 3. If you got that, great. If not, it doesn't matter. You just have to memorize it. So this is called, and it says this triangle has a very evocative name. It's going to be called the 1, 2, root 3 triangle. Now what we're going to do is we're going to figure out this angle in the triangle. And again, I don't totally want to mess up my pretty picture there, so I'll do it on the side. So we know that the sine of this angle is 1 over 2. So the sine of that angle is 1 over 2. And so theta equals the inverse sine of 1 over 2. I said you didn't need your calculator, but there we go. We're going to use it anyway. It turns out to be 30 degrees. So this over here is, I'll do a different color. This angle is 30 degrees. And this is 90 degrees, which means that we could figure out that this over here is 60 degrees. So what we have is, I'm going to call this either the 1, 2, root 3 triangle or the 30, 60, 90 triangle. Or both, and you can remember those things. If you forget which goes where, just remember that the smallest angle is across from the smallest side, and the biggest angle, which is the 90, is across from the biggest side, because 2 is bigger than root 3. So that's the first special triangle. We're going to make another special triangle. So this is actually going to be an isosceles triangle. We're going to say it's 1, 1. And I'll kind of do some calculations on the back of the page for that one. So we know that 1 squared plus 1 squared equals the hypotenuse squared. So 2 equals x squared. So x equals root 2. So this tells us that the hypotenuse of this triangle is root 2. And if you want to figure out the angle of this triangle, well, it's isosceles, which means that these two have to be the same. They have to add up to 90, which means that these are both going to be 45-degree angles. And I'm going to call this the 1, 1 root 2 or the 45, 45 triangle. Those are quite the names. I came up with them myself, more or less. Now, why would we care about these special triangles? So remember we said we were going to try not to use the calculator. So the goal is to try and do trigonometry without the calculator. So let's say, for example, I say, what is the sine of 60? Well, you say, okay, sine of 60, I know this special triangle. So the sine of 60 is going to be, that becomes the opposite, that's the hypotenuse. So the sine of 60 is root 3 over 2. What is the tangent of 30? Tangent of 30, we're back to this triangle. So tangent is opposite over adjacent. So the tangent of 30 is 1 over root 3. What would be the cosine of 60 degrees? So we're at 60 degrees. That's the opposite. That's the adjacent. Cosine is adjacent over hypotenuse. So the cosine of 60 is going to be 1 over 2. And then what would the tangent of 60 be? And the tangent of 60 would be, opposite over adjacent, which would be root 3. We can also say what is the sine of 45. Ooh. Now we've got to go to the other special triangle. So the sine of 45 is opposite over hypotenuse, which is going to be 1 over root 2. The cosine of 45 would be, well, we could use either 45. It's still going to be 1 over root 2. And the tangent of 45 is opposite over adjacent, which is 1 over 1, which is just 1. So special triangles essentially allow us to do trigonometry without using the calculators for certain special angles.